This is Istanbul from the Hong Kong University of Science and Technology, and I'm here to present our recent paper, the RIStealth, the practical and covert physical layer attack against the Wi-Fi-based intrusion detection via the Reconfigurable intelligence service. So let's begin. Oops. So we know that the Wi-Fi signals can be used to sense the human activities and realize a set of applications. An attractive feature of it is that it is privacy perceiving because it carries information about the environment and which can enable many applications like our focus today, the intrusion detection. However, it is quite dangerous if the detection capability could be damaged by the intruder. The security and reliability of the wireless system have been challenged due to its open nature. For example, we have some jamming and eavesdropping attack in the communication, and we also have some, there have been some adversarial attack for the sensing. So, and recently, the emerging RIS, or the Reconfigurable Intelligence Service, we can call it RIS, brings the paradigm shift from the passive channel measurement to the proactive channel customization, which may cause more serious threats. For example, the RIS may be able to hide the people or object from the RF signals by, for example, reflection, scattering, or even imitating the original electromagnetic field. And there have been some work use the RIS to launch an attack. For example, there have been some RIS clocking attacks, like this one, the Chen et al. Their system can adjust the configuration to render the electromagnetic field as if there were no target present. And there are some other kind of works like the radar cross-section, we can call RCS reduction attacks, and their focus is to reduce the detectability of the targets by decreasing the RCS on wide frequency band and the incident angles. But unfortunately, this existing method assumes either full coverage of RIS over the target or the electromagnetic controlled environment, so which made them unpractical and unrobust. In contrast, we focus on the practical attack in the real-world setting, that is the home-based intrusion detection. And there are still several challenges in our scenario. So the first one is the limited affordability of a practical RIS, which means that the size of the RIS should be small enough, like the back size, and for the stiffness and mobility. So we cannot use the RIS to fully cover the intruder's body. And also, the ability to control the channel is highly related to the size of the RIS. So the limited size also restricts the manipulation space of the signal. And the second challenge is the restrained cooperation in the adversary attack. Unlike the RIS and the communication scenario, the benign transceivers of the victim system have no reason to help the RIS. So the attacker has to find a way to attempt the deployment details of the victim system. And the third challenge is the complex and unpredictable environment. That means the area being intruded into may be a very complicated environment full of unknown reflectors, like the furniture and some metal devices. And before going to the detailed design of our attack, just let me introduce the threat model. So here we assume that the attacker has no prior knowledge about the victim system, like for example the precise location of the transceivers. And the attacker is equipped with a passive RIS and a receiver like a mobile phone that can acquire CSI. And for the victim system, a pair of transceivers are deployed to detect any intrusion in the monitoring area, but the system should ignore the motion of, for example, the pad, the curtain, the robot, and so on. And we also assume that a very common adaptive threshold mechanism is adapted in the victim system, and this system, this mechanism is used to handle a very common phenomenon in Wi-Fi sensing. That is, the motion signal will vary across different time, different environment, and different devices, and so on. And with the adaptive threshold, and the threshold will be automatically adapted to the noise level and to maintain the high detection rate and the low false alarm rate. And finally, the goal of the attacker is to intrude into the monitoring area without being detected. And when he succeeds, for example, he can cut off the power cables, steal the valuable, or even do harm to the owner. So that's the threat model. And let me introduce our observation about this problem. So intuitively, we have two ideas to avoid being detected. So the first is to reduce the reflection energy and keep it lower than the threshold. And the second one is to try to lift the threshold. And here we claim that the RIS is more suitable to conduct the motion reflection reduction in the far area and the threshold lifting in the near area. This is because when the attacker is close to the victim system, and just as we just said, the RIS cannot fully cover the whole body. So the uncovered link will still cause enough reflection to trigger the alarm if it is close. And for the latter one, for the threshold lifting, if the RIS is very far from the victim system, and it will only control a very little part of the energy, so that it cannot hide all the motion of the intruders. So here we find that these two methods can complement each other in space, so one in near and one in far. So that is our attack RIStealth. So we combine both methods to form a practical scheme like this figure. Let's take an overview of our attack. So we propose a two-phase attack that combines the reflection reduction and the threshold lifting to handle the limited affordability. So the first is the first phase, the sneaking phase. So the goal of the sneaking phase is to make the intruder approach the protected area sneakily and reach a pre-specified position. And then he can just facilitate the second phase, or we can say the radio blast phase. So for the radio blast phase, the goal is to lift the threshold so that the intruder's afterward movement will not be detected. Okay, so then is the workflow of our attack. So before launching the sneaking phase, the attacker must determine the RIS effective working range in advance, for example, like in his home. And then he needs to roughly localize the victim system. So he can use some simple localization like the Zhu. For example, he will just walk around the victim's home and he can roughly localize the transmitter and receiver. And then he needs to estimate the switching point, like this figure here, from the sneaking phase to the radio blast phase, based on some information like the transceiver's rough location, the entry, and the RIS effective range, as I just mentioned. And then he's prepared for the sneaking phase. He can just initiate the sneaking phase and until he reaches the switching point. And during the sneaking phase, he will redirect the energy toward the ground to avoid the unpredictable multipath due to the furniture and the metal devices around, the potential furniture. Oh, sorry. And then we have tried some intuitive method, like for example, the non-linear signal toward the direction of the receiver. But we found that this kind of method will fail when the direction is just slightly unaligned. For example, you can see in this figure, when the direction is slightly unaligned, the energy could be quite significant, and that will trigger the alarm. And here we also involve a beam broadening method to improve the robustness, since a wider beam can tolerate the larger unalignment. And now the attacker has finished the sneaking phase and has reached the switching point, so he needs to prepare for the radio blast phase. So he first needs to localize the victim system transmitter accurately with a RIS added angle of arrival estimation. So here the accurate localization is required to achieve a better beamforming. And how he estimated AOA is to enforce the RIS and to sweep the transmitter side beam, and then he collect the signal with the attacker receiver, and he found the maximal signal strength, and then he will find the corresponding transmitter direction. And also, want to increase the signal-noise ratio, so we calculate a pure RIS component with this formula. So we will first configure the RIS, the all elements to 0 and pi rapidly, and we can just calculate it with this formula, and just like this vector illustration. And now the radio blast phase is prepared, and the attacker can just launch the radio blast phase. So he will just focus the energy with the RIS and create an artificial noise to increase the threshold. So how he do it? So he will first generate the artificial noise in a similar phase shifting based way by quickly switch all the configuration cyclically to, for example, the 4 phase shift status. And you can see by doing this, it will cause a significant signal variation and thus increase the signal noise. And here, in addition, we also need to control the increasing speed so that we want to gradually increase the threshold rather than just directly trigger the alarm. So here we involve a sub-array-based activation scheme of the RIS elements to control the increasing speed. So then this is an example of the result. And please refer to our paper for more details of the algorithm. And let's come to the evaluation. So first we implement a 3-layer 16x16 element 2-bit-based RIS. And this RIS is controlled by the FPGA, and all the configuration can be done in the microsecond level, which guarantee the processing speed of our design, that the signal variation increasing and the threshold lifting. And also this RIS can be powered by a power bank, so which guarantee the mobility of our attack. And for example, we designed 2 end-to-end evaluation to test the RIS. So we test it in the live side and the non-live side scenario. So for the live side scenario, the attacker will first conduct the sneaking phase in the root 1, and then he put down the RIS and switch to the radio blast phase. And then he will just walk along the root 2, and that's one experiment finished. And for the non-live side scenario, the attacker will just directly put on the RIS here, and behind the wall, he will just launch the radio blast phase. And then he will walk along the root 1 and root 2 separately. And here it is noted that we also test the size of the impact of the RIS size here. So the result is just in the next page. And here, the AR alarm, this system is selected to be the victim system due to its practical design for the real-world setting. We choose 2 metrics to measure our attack. So the first is the duration detection rate, and the second is the case detection rate. The duration detection rate indicates the stealthiness, or we can say the detectability, or within a single intrusion. And the case detection rate in another side implies the success rate across all intrusions. And here's the result. And for the live side setup, you can find without our attack here, the system can detect almost 100% of the intrusion. But with our attack, it can detect only like 15%. So that's validate our effectiveness. And for the non-live side scenario, you can see with our attack, it can detect almost 100%. And even with our attack, it can still detect half of it. It seems not that good, but if we look at the detection success rate, like the blue bar here, you can see the duration detection rate will fall from about 75% to about 10%. That means that only the most significant motion cannot be covered. And in addition, you can see here with the size of the RIS increase, like from 8x8 to 12x12 to 6x6, 16x16, and you can find the detection rate keep decreasing. So we believe by switching the RIS to a larger one or to an active one with a more powerful ability, it is possible to launch the non-live side scenario. And we also conduct very many evaluations on various factors on the 2 phases separately, and those evaluations prove the robustness of our attack. So please refer to our papers for more details of the evaluation. And let's conclude our work. So we studied the threat of emerging risks to the security of our sensing. We are designing and demonstrating our attack to spoof the Wi-Fi-based intrusion detection. And then, by fully considering the underlying intrusion detection mechanism, our attack features a dedicated two-phase attack scheme, integrating the motion reduction and the threshold lifting strategies on the practical risk to covertly cover a moving intruder. And finally, our real-world evaluation validated the vulnerability of Wi-Fi sensing against the RIS-added attacks, as well as the robustness and the practicality of our proposed attacks. So this concludes our work. So thanks for listening, and I'm ready for questions.
Thank you for the presentation. So we can get one or two questions, I guess. Any questions from the audience? Okay. Yeah, you have one.
It's a long way. I can be loud.
Yeah.
So you were assuming that when you are doing the radio blast, so the detector will increase the threshold. So it can be sometimes obvious, right? So I mean, there is some radio blast, so something is happening. They might be not able to detect if it's like person moving or if there is some other reason, right? So you have to rely. I mean, it's you have to ask. You cannot hear me, or
Not really.
oh, sorry.
So you are assuming that, wow, this is much louder. So you are assuming that the system, when you are doing the radio blast, the system will increase its threshold, right?
Yeah, the increasing threshold.
But they still might be able to I mean, they detect the radio blast, so they can increase, I mean, they can do some other measures, right? But of course, there's nothing we can do to fix that, but
you mean to detect the increased threshold?
yes.
Yeah, that's it. But there are two points. So the first point is for the current intrusion detection design, we have to involve the adaptive threshold mechanism. So this is first. So if you try to design some additional algorithm to detect such pattern, and this will maybe sometimes it will succeed, but it will also increase the false alarm rate because it will hurt the normal case. And also, so here we, for the convenience, we just make the threshold just keep increasing. But actually, the activation scheme, we can just, for example, just like we up, down. So it will be very hard to detect such mechanism, such threshold pattern. So it is all depend on the attacker's design. So that will be very hard. And for the second is, we want to raise the concern about this because why we choose the intrusion detection? Because it is the very rare products for the Wi-Fi sensing, and there have been some company that's just selling the intrusion detection. And we don't think that they have noticed this kind of attack. So I think it is kind of to raise their concern. So that's the second point, and that's our purpose.
Thank you.
Thank you.
Any other questions? Yeah, one more.
Thank you for your impressive talk. I'm Lodi from the Shanghai University. I have a question. My question is that so you use the RIS to attack the intrusive sensing, right? But have you think about to attack other types of Wi-Fi sensing, such as gait recognition or human activity sensing? So what's the difference from the other sensing tasks and the intrusion sensing?
Yeah. Thanks for your question. So the first is actually we have tried to attack other Wi-Fi sensing. For example, this one is the previous work we have done. We use like a full duplex device to attack the gesture recognition. So this is the first. And why we choose the RIS to conduct such attacks, it is that the RIS have a much more powerful ability to, we can say, customize the channel. And here, we say that the RIS is used to lift the threshold, and in other words, we can say it is increasing the artificial noise. So let's introduce a concept similar to the SNR, the signal noise ratio.
Okay.
Yeah. So you know that the effectiveness and the range of the Wi-Fi sensing is highly dependent on the noise.
Yeah.
Yeah. So generally, if we just talking about the harm of the RIS to the whole Wi-Fi sensing, a very important point is that it will increase the noise and thus decrease the effective range of the Wi-Fi sensing. So that's the first thing we need to know. And for the second one is, I'm not sure, but do you know the concept of the ISINR from the Daqing Zhang? So he introduced this new concept for the Wi-Fi sensing, and you can just know that it is similar. So with a much higher noise, and here the noise is generated by the attacker, but with the higher noise, the effective and the accuracy of the Wi-Fi sensing will just commonly decrease. And yeah, so that's what we want to demonstrate, that the RIS-added attack will have an impact. Yeah.
Yeah, I think so. So you mean basically the RIS-based attack can attack different types of Wi-Fi sensing tasks?
Yeah, theoretically.
The method to achieve it is to something like you reduce the SNR, right?
Yeah, because you can just imagine that if the noise is kind of real larger and the useful signal, will be overwhelmed by the noise. So,
okay, thank you very much.
Thank you.
Okay, thanks a lot. So in order to be on time, finish on time, let's take the speaker again.